Hello friends, I am Shraddha Sheke. Welcome to our course on software defined radio. Our unit number 1 is Introduction to SDR and RF implementation. Course objectives are to make students understand about modern radio communication systems that can be reconfigured, to understand GNU radio, to understand how SDR platforms provides easy access to wireless network system, to understand how, unlike simulation in communication projects, SDR allows easy access to both PHY and MAC, that is MAC layer, to understand the concept of cognitive radio and spectrum sharing, to understand software defined radio system and the technologies necessary for their successful implementation. So these are all the course objectives. Then let us discuss about objective of this. Let us talk about what are the course outcomes. After the successful completion of the course, student will be able to compare SDR with the traditional hardware radio, that is HDR, then implement modern wireless system based on the OFDM, MIMO and smart antennas, build, experiment with real wireless waveforms and applications accessing both PHY and MAC, compare SDR versus MATLAB and hardware radio. Work on open projects and explore their capability to understand their own communication system, understand the concept of cognitive radio and spectrum efficiency and spectrum sensing, and understand how analog and digital technologies are used for software defined radios, topologies and applications of those networks. Now let us talk about what are the objectives of this lecture. First, we will discuss about introduction of the SDR. What is SDR? That we will talk about. Then we will discuss about what is the need of SDR. Then after that we will talk about what are the principles of SDR, that is the software defined radio. Then advantages of the SDR. Then we will discuss about what is GNU radio. So let us start. First, what is hardware defined radio? All of you must have seen this radio in our old days. So all the components, everything was hardware, and you must have listened about old songs and FM radio. So basically hardware defined radio is traditionally implemented in hardware. For example, mixers, filters, amplifiers, modulators and demodulators, detectors, etc. So all these components are implemented by using hardware. So that is nothing but hardware defined radio. This is the block diagram of analog radio receiver, which was basically used in hardware radio. So here you will observe antenna is there, then RF amplifier is there, right? Then analog local oscillator is there. So obviously you must have studied this in communication, that two frequency components are there and you will be getting addition as well as subtraction component, right? And so you are having IF amplifier and filter. So demodulator block is there, which is also called as detector block, and then it is given to the audio amplifier and then given to the speaker. So you are having filters and amplifiers everywhere, but in hardware defined radio all these components are implemented by using hardware. So everywhere you will be having are having this type of the hardwares. So all these blocks are implemented by using the hardware. So this diagram shows the frequency conversion. Here you know the mixer translates the input signal band to the I frequency, and this is the analog local oscillator, right? Now, there are certain disadvantages of the analog receivers. What are that? Lack of flexibility. So this is one disadvantage, that it's not flexible. One receiver is designed for one communication system, right? So you need to buy, or you need to take hardware components, and you need to design the one receiver for one communication system. So likewise, if you have to design various communication system, you need to design various receivers for that. As more and more mobile communication standards emerge and coexist around the world, a multimode radio receiver would certainly be significant advantage. Then limited encryption capabilities. So these are certain disadvantages of the analog receivers. Then what to do? You can see on this slide an increasing number of the wireless standards are there day by day. GPS, cell phone, then you are having USB, Wi-Fi, Bluetooth, Zigbee, HDTV, everything is increasing, right? Then the problem. What is the problem? The number of standards exist for terrestrial communications. Cell phone communication standards change every few years. Satellite ground station would like to listen to the multiple spacecraft, some launched in 1970s. Spectrum space is precious resource. Each frequency is owned. How to deal with the new technologies like ultra wideband, which is UWB. So this is the problem. Now what to do with that? The solution is software defined radio. What are the features or what are the advantages? It is flexible, which was the main disadvantages of your hardware radio, that it was not flexible, but now you can see the software radio is flexible. Flexible radio system that allows communication standard to migrate. Flexible methods for reconfiguring a radio in the software. Flexible intelligent system that communicate via different protocols at different times. Why should you or anybody care about SDR? So you can see this diagram, software communications architecture. A radio based on DSP software. Basically this, you can see, this can be considered as a one device, right? You are having various knobs, light, alarm, set, data, and can also be used as a, for example, if you are having a if you are using a digital radio, right? So radio based on the DSP software, based on the custom built procedural processing loop designed for the particular signal. So software communication architecture. You can see, a computer can also be, in a computer you can use various softwares for Photoshops, then you can use this for gaming, right? Then various mathematical calculation, you are having Adobe Acrobat, MS Office, but can this computer can be used, is it possible to use this as a radio? Can a radio be designed like this, all these softwares? So answer to all this question is yes, which is a software defined radio. So what is basically SDR? In this diagram you can see you are having one laptop and some devices there and one antenna is there, right? So software defined radio is general term referring to any radio design that uses a computer and some controlling software to define that radio's operation. Most of the today's ham rings incorporate at least some level of software definition of their operational modules. A true SDR has very little hardware and variety, and virtually every aspect of its operation is performed by the controlling software. Software defined radio. One more definition given by SDR forum is that radios that provide a software control of the variety of the modulation techniques, wideband and the narrowband operation, communications, security functions such as hopping, and the waveform requirements of the current and evolving standards over the broad frequency range. So this is nothing but the definition of the SDR, which is given by the SDR forum. Now let us talk about origin of the term software defined radio. So in 1970s, digital receiver was developed. Then in 1984, software radio came into picture. Raytheon basically digital baseband receiver. Then in 1991, software radio reinvented by Joe Mottola. In 1995, software defined radio at an event sponsored by USAF and DARPA. Now software defined radio, let us talk more about it. It is a radio communication system where components that have been typically implemented in hardware such as mixers, filters, amplifiers, modulators and demodulators, detectors, etc., are instead implemented by means of software on a personal computer or embedded system. So it is in very simple language. So what you are doing in a computer, in some software, by using some embedded language, you are actually defining these hardware components as their functionality, and it will work as a software defined radio. So in simple terms, you can see a radio which some or all of the physical layer functions are software defined. So what an SDR? The biggest reason to have a software defined radio is the flexibility it offers to the users. Filtering can easily be changed depending on the needs. Then modes of operation can be changed to accommodate the new communication technologies. All of these functions are controlled in the software rather than hardware, making changes simpler. So it is very easy to actually change the frequency or some programming part instead of buying a new component and then replacing that component and doing all the connection things and everything. Some of the biggest features is the ability to look at or view a chunk of the radio spectrum, all the frequencies at the same time to find the stations or places to operate. SDRs can also output and recovered signals to a PC, and the chunks of the spectrum can be stored as dot wave files and replayed after later for analysis. Now features of SDR. Software defined radio is converting hardware problems into the software issues. Software defines transmitted waveforms in real time. So in real time also we can actually receive the signal. We will discuss this while we will talk about the applications of the SDR. Software demodulates received waveforms in real time. So it also demodulates what are the waveforms it has received. Contrast to the most prevalent systems. Revolution in the radio design. Right now let us talk about what are the components which are required in software defined radios. So one thing is clear that everything is defined in the software, right? So what components you will require? So it is very easy, you require only 3 components like this. This is a receiver, so you can say it is a SDR receiver, then antenna and one computer. So mainly you require these 3 components. What it consists of? Programmable gate arrays, digital signal processors, general processors, an antenna, a digital to analog converter and analog to digital converter. Now let us talk about software receiver. In first part of this video we have gone through the hardware radio receiver. So you will observe you are having antenna, then RF front end, then you are having ADC, then FPGA, USB control, and then it is also given to the personal computer software defined radio receiver. Software runs on the top of the PC operating system just like any other applications. Now let us talk about what are the advantages of a software receivers. It is highly flexible. This is one of the main advantage of the software receiver. Entire communication system can be changed on the go. Complex encryption technologies can be implemented. So you can implement very complex encryption technologies by using SDR receivers. Error correction, embedded signaling, control bits for synchronization. There is no image frequency. Note that the local oscillator must have the high degree of precision and stability to avoid drifting of the received signals. Now let us talk about what are the benefits of the SDR. So up till now you must be having some idea that SDR is a radio which is defined in software. So what are the advantages? What are the benefits of it? Benefits for radio frequency manufacturers and the system integrators. So what are the advantages for them? First is a family of the radio products to be implemented using a common platform architecture, allowing new products to be more quickly introduced in the market. Software to be reused across the radio products, reducing the development cost dramatically. Then other advantages over the air or other remote reprogramming, allowing a bug filters to occur while a radio is in service, thus reducing the time and the cost associated with the operation and the maintenance. Now what are the benefits for the radio service providers? New features and the capabilities to be added to the existing infrastructure without requiring major new capital expenditures, allowing service providers to quasi future-proof their networks. The use of the common radio platforms for multiple markets, significantly reducing the logistical support and operating expenditures. And other benefit is remote software downloads through the capacity can be increased. Capability upgrades can be activated and new revenue generating features can be inserted. Now, last and the most important is what are the advantages for the end users, from the business travelers to the soldiers on the battlefield. Reduce cost in providing the end user with access to obligate wireless communications, enabling them to communicate with whomever they need, whenever they need and in whatever manner it is appropriate. Then, so we have up till now we have discussed about what is SDR, what are the components required and what are the advantages. Now let us talk about what is GNU. You must have heard about GNU radio. So GNU radio is a free and open source software development toolkit that provides signal processing blocks to implement software radios. It can be used with readily available low-cost external RF hardware to create software-defined radios or without hardware in the simulation like environment. It is widely used in the hobbyist, academic and commercial environments to support both wireless communications, research and real-world radio systems. Here you can see these are the images which explains what is a GNU. So you actually, if you want to implement a GNU software, so in that software various blocks are provided, you can see, and just double clicking on that block you can adjust its parameters, right? So you need to connect those blocks to each other and save and run the program, and that system can be used, and that system will work for your whatever program you have written or according to your connection. So various signals you can receive from that. So this is one image, it is showing that with the signal which you have received. And this is how the SDR is having various applications in deep space communications and most emerging field. So in this lecture we have talked about an overview of the SDR and the introduction of the GNU. Thank you for watching. In this part of the video, we will talk about what are the things that we can do with the SDR receiver. By using SDR receiver, we are able to listen music radio. Whatever frequency we want, we can set that frequency and we can actually listen the radio signal. We can also able to listen the airband. We can listen ham radio, we can decode digital data, and we can track aircraft. So particularly this part of the video is taken from one YouTube video whose link is given. Now let us see how to listen the radio music.
Okay, so as you can see there, we have a radio station playing in the background. The top area of the screen is showing you the peaks, so each of these peaks are different transmissions, and as I move the frequency selection around and select a waveform, you'll see that it's a different radio station. So that is how you listen to normal radio. You literally just have to select the frequency and click on one of the particular peaks. Now what you'll notice is that the mode, if you look on the top left of the screen, you'll see the mode is selected WFM. WFM stands for wide frequency modulation. This is because it needs a wider bandwidth for listening to music or any other type of normal radio station. Now,
next thing we can do with the SDR receiver is to listen to the airband. Basically, airband is the allocation of the frequencies which an aircraft can transmit. It is between 108 to 135 megahertz.
Fraction 338 kilos descent to altitude 4,000 feet. Thank you. You're on left base runway 21, no cruise control. November, delay for bottom of Air calibrate 89, change of plan, heading 270 degrees. We are heading 270, can do you, mate. Super 22 Bravo, time flight number 130. Flight number 130. E26 X-ray Alpha, you with us?
Next thing we can do with the help of SDR receiver is to listen the ham radio. Basically, amateur radio is also known as a ham radio. It is the use of the radio by spectrum for the purpose of non-commercial exchange of message, wireless experimenting, self-straining, and private record, etc. So now let us have a look of how we can listen to the ham radio.
The example that we're going to be looking at here will be a transmission on 70 centimeters, which is going to be 439 megahertz. And what we're actually going to be doing here is decoding some digital audio of a mode called DMR, which is fairly new to the amateur radio hobby, maybe just a few years that it's been kind of around. The transmission itself is digital, so it's a digital kind of audio, and in the example that you can see here, I'm using an application called DSD Plus to decode it. So it may seem a bit complicated, but it's not actually that complicated. What we're doing here is taking the audio output from SDR sharp, feeding that into DSD Plus, and DSD Plus is actually converting that audio, the digital audio, into an analog audio which we can hear and understand. So let's just have a little listen to hear what it sounds like.
GD77 forum asking the time question, and people have experimented with converting the 380 code plug into a CSV file, and then trying to add that CSV file to the GD77 CSV, and it don't work.
Now, if you're wondering to yourself, what does this DMR digital audio sound like if you're not putting it through DSD to hear the converted output, this is what it sounds like. Now be careful, this is going to be very loud and very noisy, so if you're wearing headphones, just be careful. I only play a couple of seconds of this, but this is what it sounds like before it's decoded. Next on the list.
So in ham radio, we have decoded digital data into audio. But in the next application is decode digital data. So in this case, we can actually see how SDR can be used to decode the digital data into the text. So let us have a look on it.
Going to be looking at will be something called POCSAG, P-O-C-S-A-G, which actually stands for Post Office Code Standardization Advisory Group, otherwise known as pages. That's right, we can decode pages. So on the left hand side of the screen here, this is the output, and we're using an application called PDW, and it's actually in the POCSAG mode. It can decode other types of digital data as well. But for this particular example, I'm going to be showing you the pager. Now, as the transmission comes through the SDR receiver and through the software on the right-hand side, the audio is pumped directly into PDW. What PDW then does is decode it into text, readable text that we can understand. Now, the type of people that are going to be using pages may be doctors and people like that, and also there's a lot of sensors, electronic sensors, which automatically send data. So what I'll do now is I'll just let a little bit of the audio through from what the SDR is actually receiving, just so you can hear the type of tone and sounds that pages are currently making.
So next application of the SDR is we can use this for tracking aircraft.
Using the SDR receiver, you can go ahead and use two other bits of software. One's called RTL 1090 and the other one is called Virtual Radar Server. So what essentially is happening here is the RTL 1090 software is connected directly to the SDR receiver, and it's changed the frequency to 1090 megahertz, which is 1.09 gigs, which is the frequency which aircraft transmits their Mode S positioning data, along with squawk codes and high altitude speed information as well. The virtual server software actually connects to the RTL 1090. It takes its data feed and it puts it into something visual, something tangible that we can look at, rather than just looking at zeros and ones and loads of different hex codes. Now, as you can see here on the screen, this is the output from virtual server. It's web based, so it's absolutely brilliant. It runs locally on your application, and you can go ahead and look at the aircraft in your area. Now, the amount of aircraft that it picks up will actually depend on the type of antenna that you've got. Now, the antenna that I'm using at the moment for this demonstration is not actually tuned for 1090, so so it's not going to pick up as well as it should. Luckily I live on a high ground, so I am still picking up some aircraft. Now as you can see, the aircraft are moving around on the map, which is pretty cool, and you can actually click on each of the aircraft as well, and on the right hand side it'll give you a whole load of information about what that aircraft is up to, what it's doing, the name, the make, even a picture of it if it's on their database. Obviously that information is being pulled from the internet, so you do need an internet connection if you want to see all that extra information. Information about speed, altitude, heading, etc., the squawk code, the type of aircraft, the call sign, that is actually all coming down through your RTL SDR receiver, through RTL 1090 and into virtual radar. Anyway guys, I hope...
So this is how we have discussed what are the various things that we can do with the help of SDR receiver. So this is how various applications of the SDRs are which are used in the deep space communications, NASA, etc. Thank you.